16. Here we go. Logs of products and quotients, logs of powers, exponential equations. So, just reviewing the rules that are old news, but we need to make sure we remember how to use them. The first at the top are logs of products and quotients. So, take a look at them, make sure you remember them. When you have the log of a product, so the log of two things multiplied, it can be rewritten as the log of those two things added with the base the same. Log of two things being divided inside the log can be rewritten as two logs being subtracted. And then if you have two logs that are equal to each other and their bases are the same, then the insides have to be equal. So log base b of x equals log base b of y. Well then, by kind of process of elimination, we know x has to equal y. So if you recall, we can use those tools to solve log equations, or to help us. So let's look at example 1. Log of x plus 2 plus log of 5 equals 2, and we're solving this for x. Excuse me. Okay, what can we do on the left?
Wouldn't it just be x plus 2 plus 5? This is the basis. No.
Not exactly. It's two, the bases are the same. It's two logs being added. Can be rewritten as one log where the insides are multiplied then. If it's two things being added, they can be rewritten as one being multiplied. So log base 4 of what is 5 times x plus 2? 5x plus 10. And that still equals 2 on the other side. What's the step I take to solve this equation? Left, right, middle? You guys with them? Left, right, middle means what? 4 to the second equals 5x plus 10. So 5x plus 10 is going to equal 16. Subtract the 10 over, and 5x equals 6. Divide by 5, and x is 6/5. Sound familiar? I mean, technically, we would have done something like that. We learned logs in Algebra 2, so maybe as far back as Algebra 2. Okay, let's try example 2 then. Natural log of x minus 1 minus natural log of x plus 2 equals natural log of 14. What can I do on that left side?
ln to the x minus 1 over x plus 2.
Yeah. Two logs being subtracted, same base of course, can be rewritten as one log where the insides are being divided. So natural log of x minus 1 over x plus 2 equals natural log of 14. Thoughts on what to do next?
Subtract ln 14.
I don't like that idea because then I'm going to have a fraction within a fraction, which is it's just going to get uglier as opposed to better.
Since they have the same basis, can we just say x minus 1 over x plus 2 equals 14?
Mm-hmm. They're both natural logs, yes? So they're both log base e. So since they're both natural logs, then that means our insides have to be equal to each other. So we can drop the logs and we can just have the equation x minus 1 over x plus 2 equals 14. And now it's using our algebra skills. How do you want to solve this? I would just think, okay, how do we get rid of that denominator? How do we get rid of the fraction? And to get rid of the denominator of the fraction, multiply by that denominator. So I would multiply by x plus 2. What you do on the left, we do on the right. On the left, what happens when I multiply by x plus 2? X plus 2's cancel. We have x minus 1. On the right, what happens when I multiply by x plus 2? Distribute. 14x plus 28. What? Okay.
13x equals negative 29.
You can either plus 1 and subtract 14x, or you could subtract x and subtract 29. Doesn't really matter, does it? Either way, you will get there. If I subtract 14x over, it's negative 13x. If I add 1 over, I'm at positive 29. Or Jack said 13x equals negative 29 if you went the other way. Either way, what do I end up with as an answer? Negative 29/13. You guys okay with that stuff? Okay. Logs of powers. Do you guys remember this rule? We've used this rule a lot. If you have a power, an exponent, up on the inside of a log, that power can be moved out front to become a coefficient of the log. And we can also, then that coefficient could also be moved up to the power when necessary. Okay, that's the technique we're going to add here. So, 2 log base 8 of x plus log base 8 of 4 equals 1. What do you think we should do first? What did you say?
Make the 4 on the log cube 4 2 to the second. And then we'd be able to make the 2 to the front.
And then what would you do after that, though?
I didn't get that far. I was just
Okay.
step by step.
Okay, because that's what I was trying to think. It says you're doing the opposite of what I would do here. But so he took 4, changed it to 2 squared, then that 2 can come out front. But then they're not like logs. So I'm kind of stuck with what to do there at that point. Instead of giving this one a power, or take this 2 and move it up to the power, because once I have no coefficients, we'll be able to combine these logs. That's the direction we need to go. And so if this becomes log base 8 of x squared plus log base 8 of 4, now that I have 2 logs, once there's no coefficients in front, it's 2 logs being added, so what do we need to do? Rewrite them as 1 log where the insides are being multiplied. So it becomes log base 8 of 4x squared equals 1. How I got to where I'm at?
The 4x squared, I was like, I see an x squared, and I kind of thought like the 4 was like on top of something else. So I was like, wouldn't the 4 and the 2 be the same?
No.
Yeah. Right.
Yep, just 2 logs being added can be rewritten as 1 log where the insides are multiplied. What's my next step? What'd you say, Riley? Left, right, middle is what I was going to do.
Oh, that's what I said.
Oh, now they'll own up to it. Now they knows it's right. Okay, that's what I would do at this point is the left, right, middle, because we're still trying to solve for x. So what do we have here? Okay, 8 to the first equals 4x squared. So then divide by 4, and we end up with x squared equals 2. square root it. X equals plus or minus square root of 2.
Bingo, bango, bongo.
And we have to check these.
Why should I consider checking this answer? Because I came up with a plus or minus. And here's the deal, guys. Remember, the inside of a log cannot be a negative. Okay? And right here, this was log of x, yes? So you would have, could we use the log of negative square root of 2? Now, if you do log of negative square root of 2 in your calculator, it's going to deny you.
Isn't it squared?
But it's not technically a squared. The original problem is written as 2 times that. And you can't do that log to begin with. So the only working answer is x equals square root of 2.
What's the negative extreme solution? Is that what they would call it?
Yeah. The visual, do you guys remember what the log graph looks like? The log graph is the one that starts down low along the y-axis, crosses through 1, 0, and goes up and over to infinity. Yeah. What do you notice? Are there any negative x values used? No. Okay. So that is the idea there. So log of negative square root of 2 is undefined.
Would we need to state that?
No. I'm just giving you the background of, okay, this is why, this is how you can think about it.
So if you get a situation where there's,
Like 2 answers like that.
you know, you said like we couldn't automatically put it in because of the 2 out front. What if there wasn't a number out front? Would we need to plug it in and check it then?
You still couldn't do
Or
it.
just no.
Okay, moving along. Example 4. Negative 2 natural log of 3 minus natural log of x minus 1 equals negative natural log of 1/4. I'm thinking on that for a moment.
Wait, what did you say?
We can make them all positive for football and science. They'd make
You
it
could distribute a negative to it.
He's saying multiply both sides by a negative to get rid of that overabundance of negatives. It's totally not the direction I was going to go. However, I was
Would it
processing.
make it easier?
I think it might. I do. That's why I was. Now the thing is, it's totally avoiding like using our, the rules I was going to use. This is why I was okay. So hold on. So that becomes. I mean, I'm just making sure here. I don't want to get into this and then I don't want to go all the way through and solve it and then it doesn't work.
That'd be a lot of water.
Yeah, exactly. So that becomes that. I think it will work. Let's try it. Let's try it. I'll apologize now if we have to backtrack. Okay.
I got 9x minus 9 equals 1/4.
Ooh.
Let's try it.
37
Sounds like it's going to work out.
You gave it. So I think so.
I think it's going to work out. Okay,
Is
so.
that supposed to equal 1?
Huh?
Is that supposed to equal 1?
No.
I don't know if I did my math wrong.
You were headed in the right direction. We're going to try this. Again, I'll apologize later if we totally have to backtrack and I have to use a ton of whiteout. But actually, I'll just scribble it out is what I'll do. But okay, multiplying by negative. We're multiplying by negative because it's going to change all of our signs. So now I have positive 2 natural log of 3 plus the natural log. It's still an x minus 1 inside that, right? And then equals the positive natural log of 1/4. Okay. Now what?
Bring the 2 to the power.
Okay, take the 2 to the power. So then it becomes natural log of 3 squared if you want, plus natural log of x minus 1 equals natural log of 1/4. We all know that 3 squared is 9. Okay. 2 logs being added,
You just multiply.
1 log being multiplied, yes? So this is going to become the natural log of what? 9x minus 9? Because you're taking that 9 and you're distributing. Are we okay with that? Equals natural log of 1/4. Natural log equals natural log. Insides equal each other. 9x minus 9 equals 1/4. Finish it off. So you're adding 9 over there. When you add 9 to 1/4, when we add 9, what is 9 in terms of fourths? It's 36 fourths we're adding, right? If you're adding 9 to both sides, you're adding 36 fourths plus 1/4 is 37 fourths. Dividing by 9, or what's a better way to say this? Multiplying by 1 over 9. And the reason I would say multiply by 1 over 9 is because that's going to make it easier on the other side with the fractions. So we end up with x being 37 36. Well, I had heard you say 37, and I knew you had a 9 and a 4 left, so I'm like, okay, it's going to work. And then when you came up and said 1, I was like, I don't know what you did, but it was going to work, I could tell. Now,
So did you do something like totally different last year?
oh yeah, this is my previous notes, okay? But, so what I did is I took negative 2 to the power, so 3 to the negative 2, which makes it 1 over 3 squared, or 1/9. So then you have these two being subtracted, so I rewrote them as division. This over here, you take the negative, 1/4 to the negative 1, flips it and makes it 4. So now you have insides equal to each other, so you have this fraction equal to this, multiply the x minus 1 over, distribute, add the 4 back over. It's a little bit of an uglier beginning. So that's why once Wade said that, I thought, well, it seems like it'll work. Logs do funny things sometimes, so that's why I hesitated to just go like, yeah, it'll work, let's do it.
So if we have one like this on our homework, it might not work if we change it to a positive. There would be possibility.
Well, it should work.
Find out.
It just might not, you might not have like all negatives across the board. So it might, change things up. But
So should we always plug it back in and check everything just to make sure, or?
no, because honestly, the steps made sense here. You can plug it back in, but in this case, it wouldn't be bad, it would be okay. So just remember, when you take a negative exponent, it takes something to the denominator, right? Those are the trick we kind of skipped over. So anyways, okay. Exponential equations is going to be our backside. The comments here give two methods to solve exponential equations. One, match the bases. So when you guys did this back in Algebra 2, we had the yellow or blue papers, right? We were trying to get the bases the same. The other is to take the logs of both sides and pull down the power out front. So, let's see what we can do. Cassidy, you do or don't remember? It'll come back to you. You've done this in Algebra 2. You've done this in Pre-Cal. It's not, So So start by asking yourself, on every single problem we do today, I'm going to start by asking myself, can I make those bases the same by rewriting the powers? So can 8 and 16 be rewritten in terms of powers? Yes, they can both be base 2, yes? What is 8? 8 is 2 to the third. What is 16? 2 to the fourth. So we're going to rewrite these with base 2. So right here for 8, it's 2 to the third, and then that third is going to multiply by, it's a power raised to a power, so it's going to multiply by 3x plus 2, and it equals 2 to the fourth. By rewriting it with bases of 2, my bases are the same. If the bases are the same, then the powers are the same. So if the bases are equal, then the powers are equal.
So we're pulling the power down, is that going to be equal to each other?
Yeah, pretty much. We're dropping out the bases of 2's, and we're saying the powers equal to each other. 3 times 3x plus 2 is... You did it fine, Wade.
Oh, okay.
I can't multiply. Okay, so 9x plus 6 equals 4. Unless you're looking at a different mistake. But the fact that I wrote 4 was supposed to go unnoticed at first. That was my mistake. Okay, what'd you guys do? If it's 9x plus 6, minus 6, so 9x equals negative 2, and x is negative 2/9. Okay, example 6. Can 10 and 8 be rewritten with the same basis? No, because 10 is 2 times 5. There's no rewriting that. So the other option is to take the log of both sides. So when we say take the log of both sides, that just means write the word log in front of each side. So log of 10 to the negative 2x plus 2 equals log of 8. What's our power property allow us to do? Take that power and put it out front. So I have the power, negative 2x plus 2, and I'm going to put that in parentheses because that's more than one thing, times log 10 equals log 8.
Can't you just right here middle it? And then do it that way?
You don't want to left, right, middle because my x is not... Actually, you can't left, right, middle when you have that negative 2x plus 2 out front. Left, right...
I mean before, with the original one. 10 increases to negative 2x plus 2.
Oh, like reverse your left, right, middle?
Yeah.
Possibly. You'll end up in the same place.
So maybe that's like log 8 minus 2 over negative 2.
Yeah, you'll end up in the same place. Okay, guys. There's a couple different things we could do here. Now, however, I almost overlooked the easiest thing we could do. We could. Log 10. What base is this? This is base 10. What do you know? Maybe. What do you remember? A log when the inside and the base are the same number. Equals 1. So log base 10 of 10 is 1. Or if this was log base 5 of 5, that would be 1. Or, any number you throw in there. So the idea is this right here, since it's log base 10 of 10, is going to be 1. So if this is 1, we're really just left with negative 2x plus 2 equals log 8. Glad I looked at my notes on that one. I almost overlooked that minor detail. Because I forgot the log of 10 is 1. What can I say? How do we solve for x?
Will we be keeping the logs?
I'm just going to leave it as log 8, and when I get to the end, I'll plug it into my calculator.
Okay.
I mean, Because otherwise I'm rewriting a decimal a bunch of times and okay, it's log 8 minus 2. I'm going to put negative 2 plus log of 8. And the reason I do that is because log of 8 minus 2 is that minus 2 in the log or not in the log. So that's why I put it out front. Then divide by negative 2. So x is negative 2 plus log 8 all divided by negative 2. Plug it in the calculator and get an answer. Either do negative 2 plus log 8 and then hit equals and then divide by negative 2, or use parentheses around that first part. Do we have an answer?
We'll go 4 decimal places.
I have 4 decimal places written down.
5, 4, 8, 5.
Yeah, I agree.
That's what I have in my notes. Okay. Example 7.
Yes, these aren't that bad. I didn't remember this.
Example 7. Can E and 5 be written with the same base? No, that's a given no. So what am I going to do differently about this problem? Now we're not timesing it, but we're taking the log, but when we take the log, notice he said to take the natural log because there is an E involved. And remember, natural log is base E. So natural log of E to the negative 2x plus 3 equals natural log of 5. I could have done it a step before last time. What base is this natural log, did we just say? Do you remember the rule right there? Well, it's natural log. Yeah, this is 1. But since the power, that power is what remains. And so when you have natural log or any log, and these bases are the same, it's just equal to whatever's in the power. So negative 2x plus 3 equals natural log of 5. I would. I don't care for writing a bunch of decimals down. So we're going to subtract 3. So I'm going to write it as negative 3 plus natural log of 5. Divide by negative 2. So x is negative 3 plus natural log of 5 divided by negative 2. Do the math.
Is it 0.6953?
That's what I have. Sorry, I'm being lazy. I'm not punching into my calculator, but these calculators are not new to you guys. Hey, I'm the teacher. I'm allowed to be lazy here. These calculators are not new to you. You guys know what you're doing there. And if you don't get it and you're concerned, you're going to ask me, right? You're going to say, why? Why did I not get it? What did I punch wrong? Okay. Example 8. What are you going to tell me? What? Take the log of both sides because 5 and 6 cannot be written with the same base. Log base 10 or natural log? Okay. And technically it doesn't matter. No. You could use, because there's not a 10, there's not an E in the problem, it doesn't matter. Whichever one makes you happy. Okay? It will all work out the same. So I agree. I normally go log base 10 here. So log of 5 to the 2x minus 1 equals log of 6 to the x minus 2. Next step.
Powers at the front.
Pull the powers out front. So then I have, now, since these powers are two pieces, I'm putting them in parentheses. So 2x minus 1 times log of 5 and x minus 2 times log of 6.
That's gonna be 1/2.
I don't know.
Minus half of 10 and 10 equals 1.
I see it like that. Does that work like that?
Then you'd also need to change log 6.
I'm not sure I want to go that direction. Well, that's the thing. It's not pretty. I'd rather leave it in log form.
Just distribute it.
And distribute. And here's my reasoning, because it won't, sometimes it will work out to be pretty numbers, sometimes it will not be. Okay? I mean, yeah, technically, I guess, you could go ahead and do each of these. Oh, wait, log of 5? No. No, because it'd be 10 to the x equals 5. So yeah, it's not even 1/2. It's an ugly decimal.
Yeah, 26.
So, yeah. So, I would prefer, because we have x's on both sides, the distribute option. Log 5 and log 6 are technically just numbers. They don't look it, but they are just numbers. So, I would prefer that we just distribute. So, log of 5 times 2x is 2x log 5. No one said this was going to be short. Log of 5 times minus 1. So minus log 5. Huh?
We're just distributing the log.
Yep. Yep. And log is just a number. I mean, it's a big, long, messy decimal. Do the same thing on the other side. Log of 6 times x is x log 6. Log of 6 times minus 2 is minus 2 log of 6. Notice I'm putting those things we're multiplying by as coefficients of each problem. We're trying to solve for x, so we need all the x's on one side. So I'm going to keep 2x log 5 here. I'm going to subtract over x log 6. Are you guys okay with that? On the right side, there's still a negative 2 log 6. And then I also needed to add log 5 over from the other side. Is that too much or is that okay? That's one of those things I'd love to just do in Algebra 2, but yeah, no. By calculus, if you've made it this far, you have those basics, and you can follow that if I say it as I go. I just moved everything at once. Okay, on that left side, we're trying to solve for x. I've got x in both terms, but they're not like terms. Yeah, remember the technique of factoring that x out? So if we factor the x out away from everything, then you're going to be left with 2 log 5 minus log 6 equals my other side of negative 2 log 6 plus log 5. If it's x times those parentheses, we're going to do what? If it's x times that big mess, we need to divide. So I'm going to write mine for the moment as x equals, it's my right side, so negative 2 log 6 plus log 5 divided by what was in the parentheses, which was 2 log 5 minus log 6. You type that in. Either use parentheses around top and bottom or use a fraction bar. There's my answer. Mm-hmm.
Something was wrong.
My computer just went off, didn't it?
Yes. Control that. Save you control.
Okay. Notice, guys, I have the same answer twice. Just because I was trying to show you guys something. The first time I used log like what we did. Just to show you, could you have used natural log just the same?
No.
Yep. Gives you the same answer. So, negative 1.3833. Be smarter than your calculator there. I will say that. No ways that you can and cannot put it in. And I guess my answer's off the screen, but
I just solved it in my head. Mental math, you know.
of course, that is such mental math. Why don't you just not use your calculator on the next test then?
I got
If you're that good.